All right, so chapter 7 is about working with radical equations. Let's take a peek at what that looks like. So if we have something like this, remember, if the number's not written there, it's understood to be a 2, so 3 times the square root of x plus 2 equals 14. We want to try to get that x out of that radical sign. So it's just like solving other equations, except we have to just deal with undoing that radical sign. So we have 3 square root of x plus 2 equals 14. How are we going to solve that? When we're trying to solve an equation, it's like we're doing PEMDAS backwards. So normally, when we're trying to evaluate an expression, we do parentheses first, then exponents, then multiplication and division, whatever comes first, then addition and subtraction, whatever comes first. For us here, when we're trying to get x by itself, we start backwards. So we're going to do any addition and subtraction first. So we're going to get rid of this first. So we have 3 square root of x equals 12. Now we get rid of the multiplication. So we divide both sides by 3 to undo that. So we get square root of x equals 4. And now we have to undo that. So this is the new part for us here. So now in order to undo that square root, we have to square both sides. So square root of x times square root of x is going to be x. So x equals 16. All right, and something that's important to do here, when we're dealing with radicals, we have to check for extraneous solutions. So that means we have to check for answers that work when we were trying to get x by itself and we got a number, but it might not work when we plug it back into the actual expression, into the actual equation, if you have a positive or negative in there. So something that's important to understand is that if you have something like this, square root of 9, the answer to that would just be 3. And even though if we had something like this, if we had something like x squared equals 9, what number times itself equals 9? That answer would come out to be a plus 3, that would work, and a minus 3, that would work. If we were just trying to solve this, the convention says, or the rule that everybody uses, is that you only use the positive answer, unless it's a different kind of a question like this, or the question says something like this, square root of 9, what's negative square root of 9? That would be negative 3, okay? So the convention in math says when you're taking the square root of something, you're always going to say the positive answer. And because when we square something, we get positives, and whatever else is going on under that radical sign might give us something that when we plug it back in, gives us a negative in there. That's why sometimes it won't work. All right, so anyway, let's check our answer here. Let's see if that answer works. So we got the answer to this, we got 16. So let's plug that in. 3 square root of 16 plus 2 equals 14. So we get 3 times 4 plus 2 equals 14. 12 plus 2 equals 14. And we get 14 equals 14. So yep, that is a solution that works. It's not an extraneous solution. If you're graphing the equation y equals the square root of x, if we did a little table for this with the x's and the y's, if x was 0, y would be 0. If x was 4, y would be 2. And if x was 9, it would be 3. If it was 16, it would be 4. So the graph for this would look something like this. 0, it would be something like this. It's going to be like a little curve. And we talked about the convention says that we only deal with the positives here. So if we pictured it going down here, those would be the negatives, but that's not part of the solution set here. So this is going to be like half of a parabola, and it's only in that first quadrant. All right, let's take a peek at what we had going on here. All right, so make sure we check it. All right, next lesson. What if there are more things going on underneath the radical sign? So here we see that there are more problems. Well, there's more to do under the radical sign. So we have 5 times the square root of x plus 4 equals 10. So again, we're thinking of PEMDAS backwards. All right, so we have addition and subtraction. We get rid of any of that first. And even though it looks like there's addition right here, that's actually not. We actually think of that more as a parentheses because it's something that's happening inside the radical sign. So that addition is part of the parentheses or the enclosures. Anything that was happening outside of the radical sign would be the addition and subtraction. So there's no addition and subtraction that we have to deal with there. Multiplication and division, yes. We have the 5, so that's what we'll deal with first. Oops, don't want that. So we get, that cancels, and we get square root of x plus 4 equals 2. And now we want to square both sides here to get rid of that. So we get x plus 4 equals 4. And then we take away 4 and we get x equals 0. So let's plug that in and see if it works. So we have 5 times the square root of 0 plus 4 equals 10. 5 square root of 4 equals 10. 5 times 2 equals 10. You see it? Yes, it works. 10 equals 10. All right. So what if we have something like this? How we deal with that? So here we have square root of 3x over 2 minus 4 equals 1. Well, thinking of PEMDAS backwards, first thing we are going to do is deal with that minus 4. So we're going to add 4 to both sides, and we get square root of 3x over 2 equals 5. And now we multiply both sides by 2, and we get square root of 3x equals 10. And now we deal with that radical, so we're going to square both sides. So we get 3x equals 100, and then we divide by 3. So we get x equals 100 thirds. All right, and now we can just plug that back in and make sure it works. Make sure it's not an extraneous solution. So the equation we had was square root of 3x over 2 minus 4 equals 1. And now we're going to plug in 100 thirds for that. So we have square root of 3, and we're going to do 100 thirds minus 4 equals 1. And solving this, these will cancel. So we get square root of 100 over 2 minus 4 equals 1. 10 over 2 minus 4 equals 1. 5 minus 4 equals 1. Yay! All right, so that worked. All right, next lesson. All right, next one. What if there's more than one radical? Is that the same? No. All right, second degree in disguise. All right, so sometimes this looks like it's going to be a square root problem, but it actually, when you work it out to try to get x by itself, it turns into a quadratic. And so here we have an x here and under the radical, and we have an x outside of the radical. So if we're in a situation like that, let me see here. So we have square root of x minus 1 plus x equals 3. The way we are going to solve this is we are going to start by getting the x's on different sides here. So let's take this x over. So we get square root of x minus 1 equals 3 minus x. All right. And now what we're going to do is we're going to try to get rid of that radical. So we square both sides. This is going to be kind of long and messy. This side turns into x minus 1, and then the other side turns into 3 minus x. And we can use the FOIL method to try to solve that. So the fronts, that's 9, outsides, negative 3x, insides, negative 3x, and then last, positive x squared. So cleaning this up, kind of writing it in the right order, we have x squared, that's going to be negative 6x plus 9 equals x minus 1. And the way we solve these is we try to get 0 on one side and everything else on the other side. So let's take away x and let's add 1. So we get 0 equals x squared minus 7x plus 10. All right, that was a lot of work. But do you see how that original equation that looked like a radical, it's actually a quadratic here? So we can try to solve this. The methods we use to solve these are factoring if we can, completing the square, using the quadratic formula. Let's see if we can factor this. So we're looking for something that multiplies to 10 and that adds to negative 7. So 5 and 2 is 10, and if they're both negative, we still get a positive 10, and we get a negative 7 when we add them. So that's going to end up being x minus 5 and x minus 2. All right, and now remember what we have to do is we have to solve. When is this going to be 0? X minus 5 equals 0. That's going to be x equals 5. So this is when x is 5, this one will be 0. And the other one, when is x minus 2 going to be 0? You probably see it right away, but just in case you don't, we could just write it out like that. Add 2, so x equals 2. So we have two solutions here, x equals 5 and x equals 2. Are we done? No, we have to plug it back in and make sure it works, right? So let's see. The original equation, square root of x minus 1 plus x equals 3. All right, so let's plug these in and see if it works for us. So we'll plug in 5 first. Square root of 5 minus 1 plus 5 equals 3. Square root of 4 plus 5 equals 3. So 2 plus 5 equals 3. So we get 7 equals 3. That is not true. So that means that this is an extraneous solution. It doesn't work. All right, let's try the other one. Let's try x equals 2. Square root of 2 minus 1 plus 2 equals 3. So square root of 1 plus 2 equals 3. And yep, that worked. 3 equals 3. So the solution to this, even though we got 2 when we worked it out, this is the one that actually works there. All right, next lesson. What if there's more than one radical? So just like in the other one, there was an x that wasn't in that radical. Here we have 2 radicals. All right, so we have 2 square root of x plus 3 square root of x minus 5 equals 0. All right, so just like with the other one, we are going to start by getting that. We're going to put a radical on both sides here. So we're going to split these up. So this is going to be 2 square root of x, and we're going to take this whole one, and we're going to take it off both sides. So take it off this side, and we're going to take it off the other side too. So it ends up being negative 3 square root of x minus 5. All right, now we have to get rid of the radicals, and we do that by squaring. So we end up with here, 2 times 2 is 4, square root of x times square root of x is x, and over here, negative 3 squared is 9, and square root of x minus 5 times square root of x minus 5 is x minus 5. And so cleaning that up, that's going to be 9x minus 45. All right, now this looks like something we're familiar with. So we can, I'm going to bring this over here. So we get 0 equals 5x minus 45. I'm going to bring the 45 over the other side. 45 equals 5x. And then we just divide both sides by 5 equals x. All right, and let's see if that is a solution to the equation. So the original was 2 square root of x plus 3 square root of x minus 5 equals 0. And the answer we just got was 9, so let's plug that in. 2 square root of 9 plus 3 square root of 9 minus 5 equals 0. 2 times 3 plus 3 times 4 equals 0. So 6 plus 12 equals 0. So we get 18 equals 0. All right, and that is actually, that's false. So that means that this one has no solution. There's no solution that works here. So the answer to this one would be no solution. You can see there's more to it than the other one had. So we are going to we'll bring this whole thing to the other side. So we have square root of 2x minus 5 equals 1 plus square root of x minus 3. Now, if we want to get rid of those radicals, we have to square both sides. So this is just going to end up being 2x minus 5. And then on this side, I'm going to write it out so we can FOIL it. All right, so fronts, that's going to be 1, outsides, plus square root of x minus 3. And then we have another one, plus square root of x minus 3. And then on the ends, square root of x minus 3 times square root of x minus 3. So these two things, when we multiply them times themselves, it's just going to be plus x minus 3. All right, let's clean up. So we have 2 of these. So 2 times the square root of x minus 3. Combine these, minus 2, and then we have a plus x equals 2x minus 5. All right, still looks super messy, so let's get this x on this side. So take away x, and we will add 2. So we have x minus 3 equals 2 square root of x minus 3. And now we want to try to get rid of that radical here. So we're going to square both of these sides. So this is going to end up being x minus 3 times x minus 3. And on this side, we're going to get 4 times x minus 3. So 4x minus 12. And on this side, we get x squared minus 3x plus 9. All right, now let's bring plus 12. So we have 21, and we have minus 6x squared, and we have 4x here. So let's bring this over. So we have x squared minus 10x plus 21 equals 0. Whew. All right, now we can try to factor. Let's see, 2 things that multiply to 21 that add to negative 10. Let's see, 7 and 3. If we make them both negative, we get positive 21 and negative 10. So this factors into x minus 7 and x minus 3 equals 0. X equals 7 will work for that one, and x equals 3 will work for this one. And now we have to go ahead and plug it back into the original. So that was square root of 2x minus 5 minus square root of x minus 3 equals 1. So let's plug both those values in and see what happens. So square root of 2 times 7, take away 5, minus square root of 7 minus 3 equals 1. So square root of 14, take away 5, which is square root of 9 minus square root of 21. 7 take away 3. It's going to be 4. So 3 take away 2, 1 equals 1. All right, so that one worked. Let's try the other one. So 7 is a solution. So for the other one, square root of 2 times 3 minus 5 minus square root of 3 minus 3 is 1. So 6 minus 5 minus, this is going to be 0. So square root of 1 equals 1. All right, so both of those solutions worked there. So neither one of them are extraneous solutions. All right, I think that's the last. Nope, we got one more. All right, radicals in the bottom. All right, how do we solve this one? So for these ones, I have some room down here. So for this one, if we have a situation like this where we have 1 over square root of x plus 4 equals square root of negative 2x. All right, so what we want to do is we want to get this square root of x minus 4 out of the bottom here. So we'll multiply by square root of x plus 4. I think I said minus, it's plus. And we'll multiply square root of x plus 4 on both sides. So then we end up with 1 equals, and if we multiply these two, we get square root of negative 2x times x is negative 2x squared, and then negative 2x times 4 is negative 8x. All right, next step, we want to get rid of that radical. So we will square this side and square this side. So we get 1 equals negative 2x squared minus 8x. And then we want to, because this is a quadratic now, and we want to get 0 on this side. So we get 0 equals negative 2x squared minus 8x minus 1. All right, so in order to solve this, because we have a leading coefficient of 2, and we can't factor that out, the method that we've been using for this is you could either solve by completing the square or use the quadratic formula. So here, if we use the quadratic formula, remember that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we look at this, we could say that our a value, that's going to be negative 2, our b value is negative 8, and our c value is negative 1. So we just plug all of those values in to these and then solve it, and that'll give us our two solutions. And if we just watch here, in the end, we end up with 4 plus the square root of 14 divided by negative 2, and 4 minus the square root of negative 14. The square root of 14 divided by negative 2. All right. And then what you want to do is go ahead and plug it back in and see if it works. And this is going to come out to be very messy if you tried to do it exactly. The book says it's fine just checking with estimates. So you could plug that in and get a decimal. And then in the end, if your decimal answers pretty much work out so that they're very close, then you can assume that answer is right. So for the sake of this lesson, for this book, that would work. If you were doing some kind of a scientific thing or very precise math, you might need to do that more precisely, but here it's close enough to check it. All right, and that's the last one, and then the next thing would be the test. So go ahead and work through those and then try the test.